Around 13.8 billion years ago, the Big Bang took place, marking the beginning of the story of our universe. Before that moment, space, time, matter, and energy were all compressed into an incredibly tiny and dense singularity. There was no time, no matter, and not even the fundamental laws of physics existed. This singularity was the extreme of nothingness, yet it contained endless possibilities. When this singularity exploded, space and time were instantly torn apart. The intense energy transformed into fundamental particles, and these particles gradually cooled down as the universe rapidly expanded, eventually forming atoms, stars, galaxies, and planets, the things we see in the universe today. All of this makes up the universe we are able to observe. However, there's a critical issue here. The universe we observe today is not the entire universe. According to current observations, the observable universe has a diameter of about 93 billion light. Scientists refer to this as the observable universe. Its size is so vast because the universe's expansion speed exceeds the speed of light, allowing us to see the furthest objects that emitted light 13.8 billion years ago, with that light taking all this time to reach Earth. But the observable universe is not the whole universe. In fact, we can't even begin to imagine the actual size of the universe. It might even be infinite. Because of this, we can't determine the true boundaries of the universe, nor can we be certain that such boundaries even exist. If the universe does have boundaries, what lies beyond them? A traditional view suggests that beyond the universe could be an absolute nothingness. In this void, there would be no time, no space, and no matter, just a pure blank. This state is beyond our imagination, because, in our known universe, time, space, and matter are inseparable. If you remove all these basic elements, can you still call it existence? But modern physics offers a more radical way of thinking. Perhaps the space outside our universe is not a void at all, but instead contains higher dimensional spaces. We are accustomed to living in three-dimensional space, where we perceive length, width, height, and change over time. But this might be just a small part of the entire reality. Imagine a creature living in a two-dimensional world. It can only sense forward and backward, left and right, but has no concept of height. If we were to place a finger into this two-dimensional world, these creatures would only see a few changing dots, unable to understand that it's a three-dimensional finger passing through their plane. Similarly, if our three-dimensional universe is just a slice of a higher dimensional space, then our understanding of the universe might be just the tip of the iceberg. Physicists have proposed higher dimensional models to explain gravity and quantum phenomena, like string theory. This theory suggests that the fundamental building blocks of the universe aren't point-like particles, but extremely tiny one-dimensional strings. These strings vibrate in higher dimensional spaces, creating the various fundamental particles we observe in our three-dimensional world. If this theory is correct, then our universe might be like a thin membrane floating in a higher dimensional superspace, and this superspace might contain countless other universes, each with its own unique physical laws and constants. This idea quickly leads to a more exciting hypothesis, the multiverse. If our universe is just one bubble floating in a higher dimensional space, then there might be countless other bubbles, each one a distinct universe. These universes could have completely different physical constants, the flow of time could differ, and even the properties of fundamental particles might be radically different. Perhaps in some universes, the speed of light is slower than in ours, gravity is stronger, and life forms beyond our understanding exist. This idea isn't just a science fiction concept, it has some theoretical support in quantum mechanics. For example, the many-worlds interpretation in quantum mechanics suggests that the outcome of every quantum event might create a new branch of the universe, meaning that every choice we make constantly creates new universes. There's also another, more tangible and mind-blowing hypothesis. Our universe could be part of a larger existence, like a cell in a body. From this perspective, Our galaxy, solar system, and even Earth could just be tiny components within this cell. Like the cells in our bodies, each one contains unique life information, but together forms a larger whole. If any of these hypotheses are true, then the place where we exist, the lives we live, could be just a small part of this grand system. Our laughter, sorrow, struggles, and confusion might just be moments in the grand play of the universe. But this doesn't mean we're insignificant. It is precisely because of our smallness that life takes on unique value. Perhaps we will never truly see the full scope of the universe beyond, but it is precisely this unknown that makes exploration so captivating. Maybe one day, when we break through the limits of dimensions and witness what lies beyond the universe, we'll realize that the questions we've had all along were just part of a much bigger mystery. The universe is vast, and life is fleeting. What we can do, perhaps, is make the most of this brief life by understanding this world as much as we can, by loving, creating, and leaving our mark.